Welcome to Chapter 8. Chapter 7 was entirely server-side. PHP ran before the page ever left the server, and by the time HTML reached a browser, the PHP was already gone. This chapter crosses to the other side of that boundary. JavaScript runs inside the browser, after the page has already arrived, which means it can react to what a visitor actually does with the page, in real time, with no round trip back to the server. Remind students they've already used JavaScript twice, without it being the focus of a chapter, the Chapter 5 hamburger menu, and Chapter 6 form validation. Today JavaScript finally gets its own proper foundation, then we extend it into CSS animations. Sit with the server-side versus client-side distinction for a moment, because it shapes everything about how JavaScript behaves compared to PHP. PHP runs once, produces HTML, and disappears. The page is static from that point forward. JavaScript runs continuously, inside the browser, for as long as the page stays open. That's why live character counters, accordion menus, image lightboxes, and smooth scroll effects all belong to JavaScript rather than PHP. PHP already sent its response and moved on. JavaScript is watching the whole time. These two tools aren't in competition. A real web application often uses both together. PHP building the page and handling submissions on the server, JavaScript handling interactivity on the client. By Chapter 9, students will use both in the same project. This is the setup slide students need before writing any JavaScript. Where does the file actually go? CSS lives in a .css file, linked with a tag in the. JavaScript works the same way in principle. A JS file linked with a tag, but the placement is different, and that difference matters. The tag belongs at the very bottom of, immediately before the closing tag, not in the way CSS is. Explain why. The browser reads HTML top to bottom, in order. A script tag in the runs, before any of the page's elements exist yet, so any querySelector call looking for an element comes back empty. Placing at the bottom guarantees that by the time JavaScript runs, every element in the body already exists and is ready to be found. This one plaque. JavaScript has three keywords for declaring variables, var, let, and const, but modern JavaScript only uses two of them. Var has scoping quirks that let and const were introduced specifically to fix. Tell students plainly, we will not use var in this course. Let declares a variable, whose value can be reassigned later. Const declares a variable, whose value is fixed at assignment and can't be changed. When in doubt, reach for const first. It communicates that the value doesn't change, and switching to let later is a one-word edit if needed. Don't skip the array/object caveat on this slide. Const doesn't freeze an array or object, it only prevents the variable itself from being pointed at something new. Students can still push items into a const array, or change properties on a const object. A function is a named, reusable block of code. Write it once, call it as many times as needed. JavaScript has two main ways to write one, and both produce the same result. The difference is syntax, not behavior. Declaration syntax uses the function keyword, the classic form. Arrow syntax equals greater than, is shorter, and is the same thing students already saw inside Chapter 5's hamburger add event listener callback, even though it was never named at the time. For this course, both forms work identically. Use whichever feels clearer. Arrow shorthand without curly braces is convenient for a simple one-line operation. The full function body with curly braces and return is clearer when the logic takes more than one step. Good news for this slide. JavaScript's if/else and loop syntax will feel immediately familiar. It follows exactly the same structure as PHP's conditionals and loops from Chapter 7, which in turn mirrored the JavaScript from Chapter 6's form validation. The logic shape doesn't change between languages, only the context. Two loop forms worth distinguishing. The for loop is the classic choice when you know how many times to iterate or need the index number. For each is often cleaner when working with an array, and you only need the value, not the index. Mention console.log here if it hasn't come up yet. It prints to the browser's developer console, F12, or right-click right-pointing arrow, inspect right-pointing arrow console, not the page itself. It's invaluable for checking that code is actually running, and that variable's whole. Every time JavaScript needs to do something with the page, it needs to find the right element first. That's the DOM, the document object model, the browser's live, in-memory representation of the page. Every tag in the HTML is a node JavaScript can reach and change. querySelector finds the first element matching a CSS selector, the exact same selector syntax already familiar from style sheets. querySelectorAll finds every matching element and returns a list to loop over. Land this point clearly. Students have already used querySelector twice this semester in the hamburger toggle and the form validation, without it being named. Today it finally has a name and a consistent rule. The selector passed to querySelector is the exact same syntax already known from CSS. Classlist.toggle has been the one JavaScript tool for changing the page so far. This slide adds 4 more, each handling a different kind of change. Text content reads or sets the visible text inside an element. No HTML parsing. the right choice for plain text. Style sets an inline CSS property directly from JavaScript. Note it's written in camel case instead of kebab case, font size not font size. Set attribute sets any HTML attribute, src, href, alt, placeholder, and so on. And the full class list family goes beyond toggle. Add and remove let you push a class in only one direction, for situations needing finer control than a toggle. Everything up to this slide has changed existing elements, their text, styles, classes. JavaScript can also create entirely new elements from scratch and add them to the page, or remove elements entirely. This is how to-do lists, notification banners, and dynamically loaded content actually work. Create element makes a new tag in memory. It doesn't appear on the page until it's explicitly placed with append, or a similar method. Append adds the new element as the last child of its parent. Remove deletes an element from the DOM entirely, not just hides it. Add event listener is the pattern tying all of this together. Listen for something to happen, then run code when it does. Click is just one of many available events. This slide is about the others. Input fires every time a text field, text area, or selects value changes. Useful for anything that needs to react as the user types rather than waiting for submit, like a live character counter. Change fires when a checkbox, radio, or select changes state, after the interaction completes rather than on every keystroke. Keydown and keyup fire on individual key presses. DOM content loaded is a special event on the document itself. It fires once the browser has fully parsed the HTML and built the DOM, meaning every element exists and is ready to be found. It's an alternative to placing the script at a small but real feature, an auto-updating copyright year and a footer. This is the kind of small detail that distinguishes a carefully maintained site from one that still shows 2019 in the corner because nobody remembered to update it. New date creates a date object representing the current moment. Get full year pulls the 4-digit year from it, and that number gets written into the span with text content. The two moves students now know cold. Find it with querySelector, set it with text content. Point out what's missing here. No add event listener, no click. This code just runs once when the page loads, does its job quietly, and finishes. Good moment to remind students that not every piece of JavaScript needs to be triggered by a user action. Use this divider to mark the turn in the chapter. Everything up to now was the JavaScript language foundation. Everything from here forward is CSS animation, a separate but complementary client-side skill for making pages move. Good spot to pause for questions before diving into transition, transform, and at keyframes, since students will be leaving pure JavaScript syntax behind for a few slides. Every CSS animation in this chapter builds on concepts already covered. Students already know CSS states, hover and focus, and class toggling via JavaScript is another way to move an element from one state to another. Transition is simply the property that makes the change between those states happen gradually instead of instantly. The transition property takes three values: the property to animate, the duration, and the timing function. Ease and out starts slowly, accelerates through the middle, and slows again at the end, the most natural feeling curve for most interface elements. Flag the all shortcut carefully. It's valid and targets every animatable property at once, but targeting specific properties is better practice when performance matters, since animating everything forces the transform lets you visually move, scale, or rotate an element without affecting the page's layout. That last part matters. When translate y, -8px, lifts a card 8 pixels on hover, the space the card normally occupies stays reserved. Nothing else on the page shifts to fill a gap, because as far as layout is concerned, the card hasn't moved. Walk through the three functions on screen: scale, grows or shrinks, rotate, spins in 2D, translate, moves without affecting layout. They can be combined on one line: transform, scale, 1.05, rotate, 3deg, and that combining is worth demonstrating live if time allows. Mention that transform pairs naturally with transition. Transform defines what the end state looks like. Transition controls how smoothly the element gets there. Together, they're behind M. Transition animates between exactly two states, the before and the after. Add keyframes removes that limitation. Define as many intermediate steps as needed at any percentage of the animation's total duration, and the browser handles the interpolation between each one. Point out the two-part structure. The @keyframes rule names the steps first, separately from the element. The animation property on the element itself is what actually plays it. The animation shorthand takes name, duration, timing function, and iteration count. Infinite loops the animation forever, appropriate for loaders, attention-catching pulses, and the gradient background coming up next. Note that the fade-in example uses ease out, which starts fast and decelerates, the right feel for something appearing on screen. Sync. One of the most visually striking effects achievable with pure CSS alone. A background gradient that slowly flows from one color to another in a continuous loop. No images, no JavaScript, no external libraries, just linear gradient, background size, and at keyframes. Explain the trick clearly. Make the gradient larger than the element it's applied to using background size, 200% or 300% width and height. Then animate background position to slide that oversized gradient across the element's visible area. Since the gradient is bigger than the element, shifting its position reveals different portions of the color range. This works on any element. Body gives the whole page a flowing background, but a hero section, a card, or a nav bar can use the same approach with its own palette. Adjusting T. CSS defines what an animation looks like. JavaScript decides when it runs. The bridge between them is the same classless technique that's appeared in every interactive example since Chapter 5's hamburger menu. Nothing new to learn here, just applying a familiar pattern to a new purpose. The pattern is always the same. Define the animated state in CSS under a class, then add or remove that class with JavaScript in response to an event. Call out the forwards fill mode specifically. It tells the browser to hold the animation's final state after it finishes, rather than snapping back to the start. Without forwards, a fade-in would make the element visible, and then immediately invisible again, which confuses students the first time they see it. Frame this as the end of the tip of the iceberg. Use this slide as the bridge before the recap, JavaScript as the engine of interaction, CSS animation as the art of motion. It's a visual summary rather than new content, so a good spot to pause for questions before moving to assignments and the quiz. 2 assignments this chapter. Assignment 1 gives students starter HTML/CSS and instructions covering 6 animations. They choose any 3 to complete. This is deliberately a controlled sandbox before touching their live site. Assignment 2 moves to their actual capstone site. Instructions cover 5 JavaScript additions, and they choose 3 to add, plus 1 CSS animation carried over from Assignment 1. Same pattern as every chapter. Build the technique on a controlled example first, then bring it to the live site. The quiz is 25 questions covering let/const, functions, DOM manipulation, events, transitions, transforms, at keyframes, and gradient animation. Remind students, this is the last purely client-side chapter. Chapter 9 goes back to the server side with SQL and PDO, where they're foe.